How would you evaluate the design of this CAD model before testing? This video will show you the world's first tolerance path finder that will validate predictability of your designs and make tolerancing tasks much easier. The example in this case is a simplified injection device where the main function is to inject a drug with high accuracy. Simplified. It works like this. The user pressed the top of the device, like a pen, and then the blue element, called the plunger, moves and displaces a volume in the white part, which is called the syringe. Uploading the model to the RD8 Design Suite and switching to a view mode, where we can see all the individual parts of the device. One of the paramount parameters for high dosing accuracy is the stroke length. The stroke length is defined by how far the plunger moves in the syringe. Let's describe it by the point of interest as the displacement between the end of the plunger, the brown part, relative to the syringe, which is gray in this view. This can be set up in the RD8 Tolerance module in seconds. Define the point of interest by selecting the plunger and the syringe. And tell the system in which degree of freedom you are interested in identifying tolerance paths. The Paths Finder automatically detects possible paths based on the CAD geometry and is the world's first of its kind. It actually finds 3 tolerance paths in this case. This is critical as it's not clear which path defines the dosing accuracy. What does this actually mean? If we study the design in detail, it is not clear if it is point 1, 2, or 3, highlighted here, that determines the end of the stroke and hereby the dosing. This is quite critical. 3 different scenarios are battling to define the dosing accuracy. This adds 0 value to the product, but increases complexity and cost due to need for more specifications. The root cause is overconstraints, which is automatically highlighted by the kinematic module in the RD8 suite. For this design, we see 3 overconstraints in the X degree of freedom, highlighted here in the 3D viewer with red surfaces. The red colors indicate this suboptimal setting. Let's update the design. Let's make a cross-section and take a look inside of the updated design. Clearances have been added to improve the kinematics. Areas shown here in the red circles. The critical red overconstraints in the X degree of freedom are now gone. No red surfaces to see. Green color in the X direction, all good. Let's go and check the tolerance path for the new design by setting up a new calculation sheet. Clicking the Auto Path Detection button and selecting the 2 parts that defines the point of interest together with the X degree of freedom. And voila, only 1 stack. Let's click it and review it. Looks correct. Let's use that one to set up the calculation. The parameter list is now automatically set up with the initial parameters, and we can filter the 3D viewer to focus the analysis. The world's first tolerance path finder guarantees confidence in tolerance stacks and ensures predictability of engineering calculations. See more in the RD8 YouTube channel.
Do you know the quality of your designs? We do.